With A/B testing, there is a challenge when testing multiple algorithms or multiple models that return different results. Let's say that we have a model that recommends you whether to buy a stock or not. And let's say we have another model, an alternative one, a new one that could also recommend you whether to buy a stock or not. And let's say that we also have a third model that operates differently and would also tell you whether to buy a stock or not. In this case, we want to do an A/B test that would have 3 or 4 treatments, because we would have the control group for the current state, and we would have treatment 1 for the alternative model, and we would have, let's satisfy ourselves with model number 2, alternative 2, as treatment number 3. And now the issue is that we would need to know whether treatment 1 is better or not better than control, whether treatment 2 is better or not better than the control group, and also we would like to be able to compare treatment 1 to treatment 2, whether treatment 2 is better than treatment 1. Because let's say that treatment 1 was much better than control, and also treatment 2 is much better than the control, but there is no statistical significance in between treatment 1 and 2, and in this case we would want to know this, whether the difference in between treatment 1 and treatment 2 is also statistical significant or not. Also, there is another issue. What if model number 2 does not have an answer? So users come into the system, he is seeing a stock price and the stock, and now this user is in the group of treatment 1. So in this case, treatment 1, let's say that the model of treatment 1 has a result for these users. So in this case, the user would get a recommendation of model number 1. However, let's say that in this case, model number 2 and the control would not have an answer, because they don't have a coverage of 100%. So in this case, we would not want to return the result of treatment 1 to the user, or we could return it to the user, but we would not want to contain the result and to take it into account, because we cannot compare really the result to model number control group and to treatment 2, because we didn't have any results. We would like to focus only on results where we have answers from the 3 models. Coverage is a different thing if model number 1 has different coverage, but it could be the case that the control model also covers others stocks that model number 2 could not cover. So we want to limit the sample of users that we get, the users that are in the A/B testing, only to those users who are covered by the 3 models. But this means that if we find that a user belongs to treatment 1 and we make a request to model number 1, then we also need to make additional requests to the control group model and also to treatment 2 model to check whether they have an answer or not. Because if they do not have an answer, then we may want to return a treatment 1 to the user, but we may not want to include those in the results of the comparison. So if a user comes and we now want to return to him the UX of the control group, then we want to check whether he would receive any result from the model on treatment 1 and 2. We could return the result of the user, but we would want to include him in the results only if treatment 1 and 2 would also have results. Then another user comes and he receives the result of model number 1. Then we want to do in parallel request to model control and to model treatment 2 in order to see that we have results. If yes, then include those in the statistical check for the A/B test. And then the user comes, different one, let's say receives treatment number 2. We want to make a request to control model and also to treatment 1 model. We can return the result to the user in any way, but we also want to double check that also the control and treatment number 1 have results. If they have results, then we want to keep those results and keep them in the sample where we would compare. So this was a brief overview into having multiple treatments and checking with the models.